In this video, we'll discuss about leading term and in the behavior of a polynomial function. That means how can we relate the in the behavior of a polynomial function with the leading term. Generally, the in the behavior, when we say in the behavior of a polynomial, in the behavior of a polynomial describes how the polynomial behaves as x approaches positive infinity, which is positive infinity, and negative infinity. So that is known as the in the behavior. For example, if you have a graph of a polynomial, let's say this is the x and this is the y, what will be the behavior of the graph when x goes to positive infinity or to negative infinity? So in order to explain about the in the behavior of a polynomial function, I'll use some template function. I would call them some template function. If you understand those template function, then you can analyze easily the higher degree polynomials. So let's see example. I think most of you know the graph of x squared, right? This is x squared and f of x is equal to negative x squared. Look at what is the degree. The degree of this one is 2, which is even degree. Even degree, 2 is even. This one is also degree is equal to 2, which is even. But the leading term is different, right? Leading term for this one is x squared, which is positive, and leading term here is negative x squared. Now, since you know both graphs, let's draw the rough sketch of the graphs. For example, the first one is it opens up, right? And if you look at the graph of the second one, it opens down. Parabola opens down. So when the leading coefficient of uneven degree is negative, then opens down. Now let us analyze here. Now x goes to infinity, x negative infinity, negative infinity. Now you can see the in the behavior is what will be the behavior of the first one when x goes to infinity. Now let us analyze. Now this is f of x, it is x squared. This is f of x negative x squared. Now for this one, look at when limit of instead as let's see, as x goes to positive infinity, f of x goes up, and as x goes to negative infinity, look at that, f of x goes up. This is in both sides goes up, right? Now the second one, when you look at the second one, as x goes to positive infinity, f of x goes down, negative infinity, it is down. And as x goes to negative infinity, the same thing, f of x goes negative infinity. You can see this one. Now these are my template to analyze any even polynomials. For example, if the leading coefficient is positive or the leading coefficient is negative. Now, based on this template, I can answer for the higher degree polynomial of even degree. Let's see, for example. Now, example. For example, let's say given f of x is equal to 20x to 8 plus 5x squared minus 10. List the end behavior of this polynomial function, in the behavior of the polynomial function. Now, this is, you can look at this one, right? So it is, now our template to analyze this one is f of x is x squared, which is related to our function, which is f of x, the leading term, which is 20x to the 8. So they have the same property, the same end property. So when you analyze this one for this function, then as x goes to positive infinity, then f of x goes to positive infinity. As x goes to negative infinity, then f of x goes to positive infinity. So the behavior is the same as long as the degree is even and the leading coefficient is positive. So if you are asked to sketch the graph of this one, the end behavior, this side it is up, this side is also up this side, up this side, when x goes to positive infinity or x goes to negative infinity. For the second one, for example, another example 2, given, for example, f of x is equal to negative 30x to 7 plus 10x to the 5th minus 5x plus 10. Now look at this one. Now when you state this one is even, let's try first with even x. Okay, 30x to the 8. Now the leading term is this one. This is the leading term, and you can see even degree, and the coefficient is negative. Now when you analyze this one, given f of x of this one, now state, for example, state the end behavior of f of x. Now when you analyze this one, make sure to compare with minus x squared, and look at the x squared. The graph of this one is down, right? So it is compared with our given minus 30x8. So in order to analyze the end behavior, you just take the leading term. Now you can state as x goes to positive infinity, f of x goes down or negative infinity. As x goes to negative infinity, f of x goes to negative infinity. So these templates are, the templates are important to analyze any degree polynomial with even even degree, and the leading coefficient is negative or positive. So I'll come to the next video with an odd degree polynomial with positive and negative coefficients.